So let's start now. Good evening. Good evening. Good evening. Okay. So good evening, everyone. Myself, Preeti Ranjan, a PMRF researcher scholar from IIT BHU. So I will take your this problem solving session. So today we will solve the big three assignment problem. So let's start. Okay. So now come to the question number one. Okay. Let's start. Question number one. Switch off the mic. Whose mic is on? Okay, so now can I start? Okay, so question number one. Dissolution of drug follow a first order. So dissolution of drug follow a first order process. क्या है? So dissolution of drug follow a first order process. So which is a first order relation? C0 initial drug concentration, C and T are the time and concentration at different time. So first we will see the first order reaction. So first order reaction is one in which the rate of reaction is proportional to the concentration of the reactant. So minus dA upon dt equal to Ka, and the first order reaction, so power will be 1. So Ka. So integrated rate law for first order reaction, d dA upon dt equal to Ka. So dA upon A equal to minus K dt. Then what happened? What happened? A screen is not visual. Okay, so Prachi, maybe your internet connection is poor. for other, screen is visual and I'm audible. Okay. So, Prachi, maybe your internet issue. Okay. So, so this is dA upon A equal to K dt. Then we will integrate both side of equations and we will take this one, this initial concentration C0 and final concentration C as upper and lower limit. So 1 upon A dA equal to minus K dt, and we will take upper limit and lower limit C0 C and here T0 and T. We all know, I think you all from math background and know this much math, like integration of 1 upon x equal to ln x. So ln c minus ln c0 equal to minus kt. So ln c equal to ln c0 minus kt, and this also you know exponential ln x equal to x. So e ln c equal to e ln c0 minus kt equal to c c equal to c0 e to power kt. So, so here we can see in this option ABCD, A C equal to C0 E K, minus K upon T. So answer should be C equal to C0 E to power KT. So answer will be B. So answer will be B. Let's come to question number 2. With reference to problem 1, if 50% of drug dissolved in 12 minutes, if 50% of drug dissolve in 12 minutes, then how long will it take to dissolve 80% of the drug? So first we will see the first part of the question, like if 50% of drug dissolved in 12 minutes, and then the next rest part of the next second part of the question is like how long it will take to dissolve 80% of the drug. Okay, so you all know this formula, k equal to 2.303 upon t log base 10 a upon a minus x. From where this formula came, so in previous slide I have showed this equation, right? So from this, this equation will come k equal to 2.30 upon t log base 10 a 0 upon a. So a here a minus x, because 50% drug dissolved, so 50% will be rest. So a upon a minus x. So let's solve this problem. So here it's given like 50% drug dissolved in 12 minutes. So first we will calculate the rate of reaction k. So k equal to 2.303 upon 12 log 10 100. Let's consider the initial drug concentration would be 100. So 100 upon 100 minus 50, and then 100 upon 50, and we all know the log 2 value is 0.303. So we will calculate, then k equal to 0.05775, or we can go directly like here like 50% drug dissolve in 12 minutes. So we will take a half life, like you we can go from here also directly, like k equal to 0.693 upon 12. This also we can use as a formula. So from this first part, we got K value, rate of reaction equal to 0.05775. Now we will come to the second part, like how long will it take to dissolve 80% of the drug. So now we know K, and here C0 we know, like A we know 100, and here 80% drug dissolves, so X 80. So now we will calculate T. So again we will put these things, this all values in this formula. So 0.05775 equal to 2.303 upon T log base 10 100 upon 100 minus 80. We will calculate, so it will come 5. We know log 5 value 0.6989, and we will calculate, then it will come 27.87 minutes. So answer will be 27.87 minutes. You all understand this? Let's come to question number 3. Using this rule, log P effective equal to minus 2.546 minus 0.011 PSA uh, minus 0.278 HBD हाइड्रोजन बॉन्ड डोनर एंड दिस इज क्या है TPSA ना yes then calculate the effective permeability of the following compound use Swiss ADME in last class I have shown you how to use this Swiss ADME so let's do it. First we will go to Swiss ADME. So we will draw the structure first here. So this is the structure, right? क्या हुआ पूरी तरीके से खुला ही नहीं था. So this is the structure. Okay, so in these questions, we need first polar surface area PSA and hydrogen bond donor. So we will see the first PSA and HBD. So here PSA is 55.98 Armstrong square and a hydrogen bond donor is 1. Right? So we write it down this formula log P effective equal to minus 2.546 minus 0.011 polar surface area minus 0.278 hydrogen bond donor. So we have seen in Swiss ADME these structures having PSA 55.98 Armstrong and hydrogen bond donor is 1. So we will put this value in this formula and we will get log P effective equal to minus 3.43. So P effective equal to NT log minus 3.3 minus 3.43 and then P effective equal to 0.000372. So answer will be the effective probability of this compound will be 0.000372. Okay. So now come to the next question. Could you please repeat question 1 and 2? Okay. So question 1, the solution of drug follow a first order process, which is the first order relation. C0 equal to initial drug concentration and C and T are the time and concentration at different time. So we all know the first order reaction is the one in which the rate of reaction is proportional to the concentration of reactant. So we all know minus dA upon dt equal to Ka power 1 because this is the first order reaction. So it will be Ka. What happened? So let's drive this equation. So dA upon dt equal to Ka. So dA upon A equal to minus K dt. We will integrate both sides of equations by using this upper limit and lower limit C0 and here we will use TT0. So we will do like this, then we will get C equal to C0 e to power minus KT. Right? So option will be B. Now the question, what happened? Tell. Or write it down. Yes, if ln is given in question. Yes, in same question, if ln is given in this in question, yes. Yeah, this equation you will use. Yeah, in your question, no, I think. Yeah, you use this equation, no? This one, this one. That's why I have gone through for these all things. This one, right? Understood, right? Write it down. Your voice is not clear, ma'am, for question. Yeah, actually somebody asked na question 1 and 2. That's why I start repeating this question 1 and 2. Sanat Kumar has asked. Yeah, yeah. So question number 2, with reference to problem 1, if 50% of drug dissolve in 12 minutes, so how long will it take to dissolve 80% of the drug? So with reference to problem 1, so we will use here first order reaction. So this is the formula. K equal to 2.303 upon T log base 10 A upon A minus X. From where this formula came, so you can refer this. So first we will take this first part of the question, like if 50% drug dissolved in 12 minutes, so what will be the rate of reaction K? And then we will go for the second part of the question, like how long it will take to dissolve 80% of the drug. So let's consider the initial drug concentration is 100. So we will calculate K using this formula. We will put all this what given in question and then K will be 0.05775, right? Then we will take this K for the second part of the questions and we will find out how long like time T. So 0.05775 equal to 2.303 upon T log base 10, 100 upon 100 minus 80. So we will calculate it, then time will come 27.87 minutes. Okay. Okay. So now question number 3. I think somebody has asked question number 3 also. In which question, Khushi? In this question? How will be this correct? Just now I have showed now this equation. So answer will be B. Yes, Dinesh. Natural log means LNC. Oh, LNPF is given. Oh no. We have, you have to multiply then 2.303. Yeah, yeah. Because I have shown here now, like in ln is there, then you have to convert in log e. Like this is the ln. So you have to calculate 2.303 log 10. Hmm. So this problem solved, right, Dinesh? Or okay. So in question 4, what is the TPSA as calculated by Swiss ADME? In this question, in previous questions. So TPSA, as just now we have shown in Swiss ADME, and this value is 55.98. Now question number 5. How many violations of Lipinski rule does this molecule exhibit? Right. So you people must have studied WSR notes like what is Lipinski rule. I just here we will revise. Like Lepinsky rule, the molecular mass less than 500 Dalton, log p value less than 5, less hydrogen bond donor less than 5, and hydrogen bond acceptor should be less than 10. If it will follow these all rules, then it will follow the Lepinsky rule. Or if it will not follow one or two rules, then there will be the violation of 1, 2, or 3 rule like that. So first we will check this structure in Swiss ADME, and then we will see like how many it's following or how many it's violating. Okay, so let's draw this structure in Swiss ADME and check. Just now I showed now. Okay, we will discuss this question later. Okay, let's draw this molecules first. So this is the structure, right? So first we will see the molecular mass. So molecular weight is here 325.49. So it is less than 500 Dalton, right? Then log p value is 4.39. Hydrogen bond donor is 1 and hydrogen bond acceptor is also 1, right? So, uh, so it's follow the Lipinski rule, like molecular mass is less than 500 Dalton, log p value is also less than 5, and hydrogen bond donor is less than 5, and hydrogen bond acceptor is also less than 10. So it's follow. There is no violation of Lipinski rule, so answer will be A. Okay. Okay. Question number 4. What is the TPSA as calculated by Swiss ADME? It is connected with question 3. Oh, your question is different, I think, question number 4. But we are not allowed to solve your assignment. We are allowed to solve some questions similar to your assignment. What happened? Which question is difficult? I am solving similar. Array. First, we should reach there, na? Right? I am right now in question number 5. Okay. So now we will solve question number 6. Using these following equations, determine if the molecule follow the BB rule. Log blood-brain barrier, this triple B equal to minus 0.0148 PSA plus 0.152 log P plus 0.139. So compound with log BB greater than 0.3 are blood-brain barrier penetrating, and compound with log BB smaller than minus 1.0 are poorly distributed to the brain. Use Zinc 15 database for clue. So we will draw this structure in Zinc 15 database because here they have given the clue to use Zinc 15 database. So let's draw this structure in Zinc 15 database and see. Okay, so this is the Zinc 15 database. Okay, so this is the structure, right? No, no, this is the structure only. So this structure came, right? Different. Yeah, yeah. That's I'm also seeing. Why it's like this? Okay, let's draw again then. Yes, this is our wandering. It will take more time again. Okay, we will do fast. Right, so this is the structure. What what happened? This is the structure only, no? Okay, yeah. Here, no? Okay. This is the structure, right? So What in question? Again, they are asking, we have to take from here PSA and log P value. So PSA is here 30. We can take 32 also, no problem. And log P value is 3.439. So, so this is the equation which given in this question. Log blood-brain barrier equal to minus 0.0148 PSA plus 0.152 log P plus 0.139. So now we will put the value of this PSA, polar surface area, and log P value. So we have taken from there 30 and 3.43 and we will calculate. So it will come 0.216. Here in this questions given compound with log BB greater than 0.3 are blood-brain barrier penetrating, and compound with log BB smaller than minus 1.0 are poorly distributed to the brain. So this value has came in between 0.3 and minus 1.0. So answer will be maybe. So answer will be D. Okay. So okay. Why, what happened, Rakesh? So now question number 7. In a molecule, a PGP efflux substrate if n plus 0 greater than and equal to 8, molecular weight would be greater than 400 and acid with pKa greater than 4. If it will follow these all things, then it will be P, P glycoprotein efflux substrate. And most likely a P glycoprotein non-substrate if N plus B smaller than equal to 4, molecular weight smaller than 400 and acid with pK smaller than 8. So let's see these molecules. What happened? So again we will draw this structure and we will see. Can you explain question 6 again? Question once again. What happened in question 6? Tell what dot is there? हाँ बोलो. Log triple B equal to minus 0.0148 PSA plus 0.152 log B plus 0.139. So we have taken this value just now we draw in zinc database and we have taken from there this PSA value is 30 and log P value is 3.43, right? Right, this 30 value and this 3.43 value. So what is problem? We will, if we will multiply this, then we will got this, and and this. Why we are not getting this? What is the problem in this? Tell. See, just now I showed now here. See, TPSA is 30 here, and log P value is here 3.439. You see? Okay, so let's come to question 7. So first we will draw this structure and we will see. So this is the structure. So here we want N plus O. Here we can count itself. Now nitrogen is 1 and 3 oxygen is there. So N plus O is equal to 4 and molecular weight is two, 217.29, and acid with pK that you can say in you can check this in PubChem is 3.7, because in this molecules this carboxylic group and is there. So this is the big acid, and the pK value of this group is 3.7. So this option, so now we will check like N plus O greater than equal to A. No, this is 4. So most likely PGP non-substrate, because N plus O is equal to 4. Molecular weight is less than 400, and the acid with pKa is smaller than 8, like it is 3.7. So answer will be A. No, it is not a P glycoprotein efflux substrate. Now come to the question number 8. Does this molecules follow Oprea rule of 3? How many violation? So what is this Oprea rule of 3? So Oprea rule of 3, like this all properties would be the multiple of 3. That's why the rule is rule of 3. Molecular weight should be smaller than and equal to 300. C log P value smaller than equal to 3. Number of hydrogen bond donor equal to smaller than and equal to 3. Number of hydrogen bond acceptor also smaller than equal to 3. Flexible bond smaller than equal to 3. And polar surface area smaller than equal to 60 strong square. So we will check these molecules, like how many violations these molecules having. So again, we will draw these molecules and check. So this is the structure. Right, this is the structure. So we will check the properties of this. Molecular weight is 212.29 gram per mole, or 212.29 Dalton. Then C log P 1.48. I don't know why today is changing everything. Number of hydrogen bond donor and acceptor is 3 and 2, and this 3 and 2. Then polar surface area is 64.39, and flexible bond or rotatable bond is 5. So now we will see, like, so here we will check with this rule. Molecular weight less than 300, yes. C log P value is also less than 3. Hydrogen bond donor is less than 3. Hydrogen bond acceptor is equal to 3. Okay. Flexible bond is 5, but it should be less than 3 or equal to 3. And polar surface area also less than and equal to 60 strong square. But here the polar surface area is 64.39. So there is violation of 2 rule. So answer will be A. Okay. What happens? Slide is not moving. What happened, Rakesh? Why you want me to use this jam file? Hello. Am I audible? What happened? What happened? Maybe your internet connection will be loose or low. Why? You people are in. So you all are in question 6 slide. Hey, please reply. I am not able to understand what is going on, because some people are telling it's not audible. Some are telling it's not visible. So for all this problem is happening. अरे, so now you are able. So now you are able to see the slide. Okay. So let's come to question 9. What happened? Okay. Question 7, right? So, is the molecule a P glycoprotein efflux substrate? Like, is this molecules like P glycoprotein efflux substrate if N plus O greater than equal to 8 molecule? Huh? What happened? Molecular weight. I'm not audible. Why? So why? Oh, sorry. Sorry. So now I'm audible, right? Okay. Okay. Sorry. I didn't check it. Question 7. Is the molecule a PGP efflux substrate? PGP like P glycoprotein efflux substrate if N plus O greater than equal to 8, molecular weight greater than 400 and acid with pK greater than 4. Most likely a P glycoprotein non-substrate if N plus O are smaller than equal to 4 and molecular weight smaller than 400 and acid with pK are smaller than 8. So we have checked this in Swiss ADME. Oh, I think I have changed the structure. Okay, you people can draw and check uh, there. So here we can see what happened. Yeah. Just now I have showed. Yeah, just now I have showed. If you want, I can draw again and show. Should I? No. So N plus O is equal to 4. Here is one nitrogen and 3 oxygen is there. So N plus O equal to 4. Molecular weight of this molecule is less than 400. Like the molecular weight of this structure is 217.29 and pK value is 3.7. So it will follow this like N plus O is equal to 4, molecular weight is less than 400 and acid with pK smaller than 8. So this molecule would not be the P glycoprotein efflux substrate. So answer will be A. Now question number 8. Does this molecules follow Oprea rule of 3? How many violation? So uh, first we know like what is this rule. The molecular this rule is like everything is multiple of 3. Molecular weight less than equal to 300, C log P less than equal to 3, number of hydrogen bond donor less than equal to 3, number of hydrogen bond acceptor less than equal to 3, flexible bond less than equal to 3, polar surface area less than equal to 60 strong square. So just now I have showed here like the molecular weight of this molecule is 212.29, number of hydrogen bond acceptor is 3, number of hydrogen bond donor is 2, number of rotatable bond is 5 and TPSA is 64.39 m strong and consensus P log P is 1.48. So we will check here how many violation is here. So molecular weight is 212.29, C log P equal to 1.51, number of hydrogen bond donor is 2, number of hydrogen bond acceptor is 3, flexible bond 5 and polar surface area is 64.39. So here the flexible bond should be less than equal to 3 and polar surface area also less than equal to 60 angstrom. So here is two violation like here flexible bond is 5 and polar surface area is 64.39. So answer will be A. There is two violation. So now come to the question number 9. If pKa of a drug equal to 3.5 and the pH equal to 2.5, then what will be the ratio of uncharged to charged concentration? So you all know this formula, right? pKa equal to pH plus log uncharged concentration upon charged concentration. So we will apply which has given in question like pKa equal to 3.5 and pH equal to 2.5 plus log uncharged concentration upon charge concentration. So 1 equal to, so 1 equal to log this, then uncharged upon charge concentration equal to anti-log 1 equal to 10. Okay. Okay. So now come to the question number 10. You all know this, right? This equation, Henderson-Helmholtz equation. So now question number 10. Hey, you all are there, right? What happened? Am I audible? Okay. So now the question number 10. With reference to problem 9, at what pH will be the ratio of uncharged to charged concentrations will be 2.5. So again we will take this formula pKa equal to pH plus log uncharged concentration upon charge concentration. So here in this questions has given like with reference to problem 9 at what pH the ratio of uncharged to charged concentrations will be 2.5. So in previous question pK is given 3.5. So we will take that pK 3.5, pH is, we will take that 3 point, or we can write this formula like this: pH equal to pKa minus log uncharged concentration upon charge concentration. So pKa it's given in previous question 3.5 minus log here given it's 2.5. So log 2.5 value is 0.397. So answer will be 3.1. So okay, all assignment question has solved. What item, Najia? Again slide not visible from slide 9. Why? For everyone it's not visible? Why this is happening again and again? Hello. So now you are able to see. Take minute. रुक जा. So now you are able to see my presentation. Now coming. Okay. So from question 9 you people are having problem. So you can write it down now. Okay, no problem. Okay, I will I will again tell. So from till question 8, okay, right? So question 9. So in question 9, if pKa of drug equal to 3.5 and pH equal to 2.5, then what will be the ratio of uncharged to charged concentration? So you all know about this equation or this formula pKa equal to pH plus log uncharged concentration upon charged concentration. This is Henderson-Helmholtz equation. Huh? Yes. If they will ask about charge upon uncharged ratio. Then you can minus here. Okay. So we will write it down what has given in this question, like pK value 3.5 and pH value 2.5 plus log and charged upon charge concentration. So this will become 10. Okay. Hey, you all are okay. Okay. Again, question 10. With reference to problem 9, at what pH will be the ratio of uncharged to charged concentration will be 2.5. Okay. So again, the pKa equal to pH plus log uncharged concentration upon charge concentration. So pKa given in previous questions 3.5 and the uncharged upon charge concentration is 2.5. So log 2.5 equal to 0.397. So answer will be 3.1. Okay, right? Okay. So now, so we can stop here, right? Jhalak, uh, in this question, uh, the option A and B, I think both are true. Because if you will add this group to the primary amine, then this PSA will uh, increase. Yeah, this PSA value will change. Uh, so this option will be correct, A and B. Hey, this Khushi, you have to solve yourself. Khushi, no, A will also be this. Yes, but that things minus now. That equation, you have to put this all things on that equation. Na? One equation is given na there. P effective. Are that P effective one formula is given there na in course. Yeah, you have to keep this values in this formula, and then we will check na P effective, right? In this, then you have to check na. I think your question is like that, and this all question you solve yourself, like this erythromycin and all, because just now I have solved the similar question. No, this is based on that formula only. This question is based on question 3 only, na? See, it's written here itself, na? Based on question 3. So what is the question 3? So question 3 is this only, na? Right? Then select any one, A and B. It will be okay. Dikshant, in question itself, it's given na based on question 3. क्या हुआ अगेन? आई एम नॉट विजुअल. गॉड, क्या हो रहा है ये? So now okay, right? So we can stop class now, right? Okay. 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 Thank you. Okay. Okay. Thank you.